Bismillahirrahmanirrahim and Assalamu alaikum, my dear students. I welcome you all to the lecture number 12 of electric circuit analysis. Today we are going to solve some numericals of the topic maximum power transfer theorem. This theorem was taught to you in the previous lecture, that is lecture number 11. Today I am going to reinforce the concept of this theorem with two examples or exercise questions from chapter number 4. So in the first question, which is problem number 4.66, we are given that we have a circuit over here. We have three sources in the circuit and we have to find the maximum value of R for which the maximum power can we have to find the value of R for which the maximum power can be transferred in this circuit. So for maximum power, you know that the maximum power transfer takes place when this load resistor or unknown resistor is equal to the R Thevenin that is provided by this circuit, and the P maximum is found by this equation, that is P max is equal to V Thevenin square divided by 4 R Thevenin. So in this scenario we now have to find R Thevenin and V Thevenin. This means at the terminals A and B, which I'll term as these two terminals, that is by extracting this R, this terminal and this terminal, I'll identify them as A and B, and I have to transform the rest of the circuit into its equivalent Thevenin resistance and Thevenin voltage and Thevenin resistance. So first I try to find R Thevenin. You know that R Thevenin is found by turning off all of the independent sources between the terminals A and B. So this was the original circuit. I identified this terminal as A and this as B. So I turn off this to find R Thevenin. I turn off this, I turn off this, and I turn off this. Please recall that the voltage sources when turned off are replaced by a short circuit, whereas a current source, when it is turned off, it is replaced by an open circuit. So this circuit now becomes this thing, and further simplifying the circuit I get this. So across terminals A and B you can see that 3 and 5 are in series. So I take the series equivalent of this, and then terminal A and B, this 2 ohm, and the combination of these two, that is 8, is parallel to this 2 ohm. So I take the parallel combination of these two, and by simply equivalent resistance of 2 parallel, 2 and 8 give me 1.6 ohm. Now I move on to finding the Thevenin voltage of this circuit. The Thevenin voltage can be found by first transforming this source into this current source into the equivalent voltage source. This can be found transformed as you know that whenever we have a resistance in parallel to a current source, it can be transformed into a voltage source in series with the resistance. The resistance value remains the same between the two terminals, that is we had 5 ohm over here and we also now will have 5 ohm. However, the new voltage source is V is equal to IR by Ohm's law. By inserting the value of 5 ohm resistance and 6 ampere current source, I get to know that the new transformed voltage source is now 30 volt. Now what I do is I replace this parallel combination by 5 ohm resistor in series with this transformed 30 volt voltage source. And please recall that I told you in the previous lectures that the arrowhead is in conformance with the positive terminal of the battery. So arrowhead was downward, that's why I have the positive terminal toward the ground side of the circuit. So we have to be in conformance with the previous rule. Now I have a simple series circuit. What I can do is I can find the current across this series circuit by applying Kirchhoff voltage law. So by Kirchhoff voltage law, you know that the voltage gain across the circuit is equal to the voltage loss across the circuit. While traversing the circuit, this is 20 volt and I'm going from low potential so high potential, so that's why it will be a voltage gain. Now I come here and this 10 volt, we also here are going from minus to plus, low potential to high potential, it is also a voltage gain. And finally the last battery, which is 30 volt, this is while traversing this I first encountered the negative terminal and then the positive terminal. Negative is the low potential and positive the high potential, so it will be also a voltage gain. The rest of the three resistors, these are the passive elements and they will show voltage loss. So you know that each of the resistance is encountering the current I. We have the same I current passing through all of the elements in the circuit. So I simply gather these 3 plus 2 plus 5 becomes 10. These three battery become 60, and by simple arithmetics I get to know that the current flowing through this circuit is 6 ampere. Now the VThevenin, that is the voltage from A to B. Can you please look at the circuit? Voltage from A to B. So you know that parallel voltages are always the same. So voltage AB is a combination of voltage 2 ohm plus this 10 volt. Now you can see that this is the plus higher potential terminal, and I have identified this as negative. Since the battery terminals are not in conformance with the Thevenin voltage, so that's why we put a negative sign over here. So V2 ohm was 2I minus this 10 volt. We just found that is the current flowing through the circuit is 6 ampere. By inserting the value of current I get to know that VThevenin is 2 volt. Now you know that in the previous lecture we found that the P maximum across the power transferred to a load resistance is R VThevenin square divided by 4R Thevenin. We insert the value of VThevenin and the R Thevenin which we just found, so we get to know that the maximum power transferred will be 625 milliwatts. Now to further understand the concept of maximum power transfer, we move on to another circuit which is given in problem number 4.67. This comes from chapter number 4 exercise problems. Here we have a bridge circuit and we have to find the value of R for which maximum power transfer can take place. So this question is divided into two parts. First of all, we have to find the value of R for which maximum power may take place, and then we have to find what the actual value of the maximum power absorbed by this R is. So as previously, you know that we have to extract the value R, the unknown resistance, and then identify the terminals as A and B, and we have to find the resistance that is provided to these two terminals. So for finding R Thevenin, you know that we turn off the independent sources. Here we have only one independent source, which is the 40 volt voltage source. When we turn off a voltage source, it is replaced by a short circuit. So this is how I get the circuit. These two resistances are in parallel to each other. These two resistances are in parallel to each other. This is how the circuit is. And finally, from A to B, this parallel combination is in series with this parallel combination as given over here. So by simple mathematics, I get to know the parallel combination of this, the parallel combination of this. By simple mathematics, what we get is the R Thevenin equivalent resistance of this circuit is 25 ohm. Now we move on to finding the B part of the circuit, which is the maximum power absorbed. The maximum power absorbed formula is this. So we don't have the value of Thevenin voltage, so first we'll find the Thevenin voltage, and then we can easily find the maximum power transfer. For the Thevenin voltage, I take the original circuit, identify terminals A, B by extracting the resistance R. So from the voltage from this to this terminal must be V20 ohm plus V90 ohm. So if I give two by mesh analysis, if I assign loop current to each of the loop, this means first loop is I1, second loop is I2. So 20 encounters the current I1 and 90 encounters the current I2. So it will be 20 I1 plus 90 I2. Now we have to find I1 and I2. I1 and I2 can be found by applying mesh analysis to each of the loop. By loop 1, voltage gain is equal to voltage loss. So 40 volt is the voltage gain, and the two resistances, that is 20 and 80, these two are voltage drop. So this is how I get to know both of the resistance have loop current I1 flowing through them. By simple mathematics, I get to know the I1 is 0.4 ohm. Now we move on to the loop 2 of this circuit. Over here, if I take the direction this, then you can see that this is from plus to minus. The voltage 40 volt is now the voltage drop, and 10 ohm and 90 ohm, both these are passive elements. They will represent a voltage drop, and the current flowing through both of them is I2. So by inserting the values, V is equal to IR, 10 I2, 90 I2, and by simple mathematics, I get to know that I2 is minus 0.4 ampere. Now to find the VThevenin, we put the value of I1 and I2 in the equation just defined, which was V20 ohm plus V90 ohm. I1, I2, I insert the values of these, and I get to know that the VThevenin or the Thevenin voltage across the circuit is minus 28 volt. Now we move on to finding the maximum power transferred, which is by this formula is equal to 7.84 watt. Thank you very much. If you have any problems, please do let me know in the question answer session relevant to this lecture. Take care. Allah Hafiz.